Good morning. So today we're going to take the next step. And last time we talked about the volume of prisms. Today we're going to talk about the volume of pyramids. So a pyramid is just basically a prism that's been chopped up a little bit. Um, we had talked about it when we were doing surface area, where it had a base, and then it was each side of those bases were each side of the base was connected with a triangle that went to an apex or a top, okay, or a point, shall we say. So now we're going to find the volume of a pyramid, and it's not that much different than what we did before with prisms, because a pyramid comes from a prism. So how do we go from a prism to a pyramid? Really not that complicated. If you think back to a triangle is half of a rectangle. Um, Technically, it's half of a parallelogram. So that's why we get area 1/2 base times height, or base times height divided by 2. I always like to have the fraction in front, just makes life a little bit easier. So now we're going to do the same thing to go from the prism to the pyramid. So if you notice, we start here with a rectangular prism. If I were to cut that in half, right, the volume of this is going to be 1/2 times length times width times height, or the area of the base times the height. Well, if you notice, this side right here is a rectangle. It is not a triangle. Pyramids have only triangular faces on top, with it can be any shape on the bottom, but you need to have the triangles on top. Well, if this is 1/2 base times height, in order for me to get this into a triangle, I have to remove some of it. So it would make sense that the formula is going to be less than that. Now, I'm not going to go through the entire derivation of the formula. I'm going to link a video that will show you how to do that. Please watch it if you would like. You don't have to, but it's just showing you where the formula comes from. So, basically we just remove some of this and eventually get your triangular faces that come off each of the bases. Now, if you notice, we do not have a regular polygon at the base. Okay, you don't have to. In the beginning, we only talked about ones that had regular polygons just because it made life a little bit easier. But now it's going to be, we can have pyramids that have different size bases. So what is the formula? Well, a couple things we need to go over. One of them is we have a height, but the height is different than when we did surface area. Surface area, if you remember, we referred to it as the slant height, because the height of it, to find the area of this triangle, you need to know the height of that triangle itself. So we call that the slant height. That is different than the height of the actual pyramid, which goes from the base of the pyramid up to the point of the pyramid. Okay. This is just a different angle from the bottom. So you got the area of the base, then you got the height going from there to the point. Okay. So like I said, it was a little bit less than 1/2 the area of the base times height. It's actually 1/3. Again, the video will show you how to do that if you want to look through it. Okay. So how do we do it? Some of them are really that simple. Once you have the formula, not a lot you have to worry about. So again, this is going to be the area of the base times the height, okay, times 1/3. So you just plug and chug. You plug the numbers you have into what you have, into the proper spot, and then you chug out your answer. Now, again, like I said, I like to use a fraction as opposed to dividing it by that number. And the main reason is now you can cross cancel. So if you think about it, I can take 1/3 of 9 and I just do 48 times 3 in my head, or I can do 1/3 of 48 and just do 16 times 9 in my head. If you can do that, if you can't, that's fine. Just pull out your calculator. You're going to come out to a pretty gross number, 144 millimeters cubed. Now, this one does not give you the area of the base, but it's not very hard to find the area of this base, is it? Okay, so it's 1/3 times base times the height. Again, it's important for us to write this stuff out, because what you can do is it's actually going to make your life a little bit easier. As math gets more complicated, the more work you show, the easier it is on your brain, and the less confusing it is, and it's actually faster. It's a weird fact, but it is. So I'm just changing the base into the area of the base into what actually the numbers I need are, which are the length and the width. Plug it in. Well, what's nice about seeing here, like, oh, 1/3 of 3 is 1. So this is really just 4 times 7, which is 28. And it's feet, so it's feet cubed, because remember, volume is always cubed. Now this one's a little different. Look at this one here, okay? So we got a triangular base, and obviously we got the 3 triangular sides, But we got a triangular base, and we have two different bases here. We have the base of the face, and we got the base of the actual prism. So when I rewrite my formula, what is it that I need? So the area of the base is 1/2 base times the height of the face. And then, it's the height of the actual prism itself, the pyramid. I don't know why I say prism so often. It's the height of the pyramid, and you multiply that by 1/3. Okay? So now you plug all your numbers in, and this looks really complicated, and in reality, it's not. A third times a half is a sixth. Well, a sixth times 6 is 1, so that just multiplies to 1. 17.5 times 10 is 175. No calculator needed. So just because I wrote it out made my life a lot simpler. So now we're going to look at a real-life application for this one. So basically what we're looking at is a bottle of sunscreen. Now, it looks more like soap to me, to be flat honest with you, but it is what it is. So the diagram shows the portion of a rectangular pyramid that is removed to make a sunscreen bottle. The portion that is removed is also a rectangular pyramid. So this was a full pyramid, and then we removed this part. Find the unit cost of the sunscreen. So if you remember, earlier this year we talked about unit rates. That is a big 6th grade concept where they talk about a unit rate, unit cost, that type of thing. So we had done stuff similar to this. Well, not us, but you did last year when you did volume of prisms, irregular prisms, where you had like multiple prisms together. And you could do it one of two ways. You could either do individual parts, or you could do the whole thing and then remove part of it. So that's basically what we're doing. We're going to find the whole prism and then remove the top part, and then we'll use that to calculate our last part. So again, we start with our formula, 1/3 base times height. We're just going to fill in the numbers. And what's nice about using the fraction here is now we don't have to do all the multiplication. We can just cross cancel. 1/3 times 6 is 2. 2 times 2 is 4. So this volume is 4 inches cubed if it was the entire thing. Now we can just plug in the numbers for the smaller one. Okay, now it looks a little weird to have a fraction with decimals, although that's really not that different because we can actually find 1/3 of 1.5, which is just 0.5. 0.5 times 0.5 is 0.25. And now we just have 0.25 squared, or 0.25 times 0.25, which is now 25 times 25 is 625. And then when we put all the decimal points in where it's supposed to be, we need to have basically multiply it by 1,000th. Actually, no, I'm sorry, a 10,000th, because it's 100th. Hundredths times hundredths gives you 10,000ths. So 0.0625 inches cubed. So that's the area, that's the volume of the top. What we need to do is find the volume of just this portion right here. So the whole thing is 4 minus the top, which is 0.0625. That comes out to be 3.9375. It's a big number. Again, calculator does all of it for you. Well, now we need to find out what will each square inch cost. So in order to do that, we need to take the price, divide it by the number of square inches. That will give us the amount, which is, oops, it's in the way, 2.53. So it comes out to be 2.53 since it's money. It's $2.53 per cubic inch. Why is that important? Because if you're working for a company who's building or who's creating these products, you need to have an understanding of what the actual cost is, so that way you know what to charge, so that way you can make a profit. There's a lot of in-depth things with this stuff. So if you have any questions, please reach out. Have a good day.